In this video, we are going to see Norton's theorem. If you not saw the video of Thevenin's theorem, I will place in iCards, and also I will put the link of that video in the description. Here, the Thevenin's theorem and Norton's theorem are both are same because this both the theorems are used to simplify the complex circuit into simple equivalent circuit. Here, what Norton's theorem states that any complex circuit is used to simplified in this Norton equivalent circuit, which contains of per current source and equivalent resistance without load, which is connected across the load resistance in such a way. So, in such that the Norton's theorem states that. Then, how to apply this Norton's theorem on the circuits? Let us see now. Means we are going to see the working of Norton's theorem. First, you should identify the load. What is the load? Now, remove load between terminals and put short circuit. Now, current through this short circuit is Norton's current, which is denoted by IN. Now, in third step, calculate IN with any of technique. Later, you should calculate this Norton's equivalent. Calculate Norton's equivalent by removing load, means opening load and replacing sources with their internal resistance. Replacing sources with their internal resistance means voltage source is equal to short circuited and current source is open circuited. Now draw the Norton's equivalent circuit as shown. This is Norton's equivalent circuit. So finally we should obtain the circuit. Now here, if I simply read this working, you may not get understand. So let us clear the concepts in more detail with one solving problem. Now what the question given? Find the current through the resistance RL. So we want to find the current through this resistance of the circuit using Norton's theorem. So we want to find the current through RL. Current through RL we want to find using Norton's theorem. Now from Norton's theorem steps, the first step is identify load resistance. So here load resistance is 1.5 ohms. In the question itself, he given load resistance is equals to 1.5 ohms. Now from Norton's theorem step 2, from above working, what is step 2? We should remove this RL and we should short circuit between the terminals, and we should draw the circuit, and considering current through this RL is IN. From step 2, if we draw the circuit like this. Now from step 2 of Norton's theorem, remove RL and short circuit between the terminals. So removing RL and short circuit between the terminals, that current through short circuit is IN. So current flow in this short is IN. Now from third step of Norton's theorem, we should calculate IN. For calculating IN, I am using mesh analysis. For mesh analysis, I am considering loop currents as I1, I2. Now to calculate IN, I am using mesh analysis. From loop 1, we get 2 plus 6, which is 8I1. Again this I2 affecting on I1 by 6 ohm resistor, so minus 6I2. This I1 touching first negative terminal of 12 volts, so minus 12, which is equals to 0. If we rewrite this, 8I1 minus 6I2, which is equals to 12. Consider this as equation 1. Now from loop 2, Here 3 plus 6, which is 9 I2. Again this I1 affecting on I2 by 6 ohms resistor. So minus 6 I1, which is equals to 0 because there is no voltage sources. Consider this as equation 2. Solving 192, we get I1 equals to 3 amps, I2 is equals to 2 amps. So now here IN in this direction, I2 also flowing along through direction of IN. So now I2 is equals to IN, which is equals to 2 amps. Therefore, after calculating IN from Norton's theorem, the next step is we should calculate Rn. How to calculate Rn? We should remove this RL and replacing these sources with their internal resistance. Here we have voltage source, so we should make short circuit between this, and here we should make open circuit. Here we are open circuiting, here we are short circuiting. Then if we draw the circuit look as follows. Now here we should calculate Rn. We should calculate Rn in this direction. Here this 2 plus 6 are in parallel, so 2 parallel to 6, and series to this whole is series to this 3 ohms. So now across A and B we get Rn is equals to 4.5 ohms. Now next step, we should draw Norton's equivalent circuit. So what is Norton's equivalent circuit? The Norton's equivalent circuit look like this. From calculation we obtained IN is equal to 2 amps and Rn is equals to 4.5 ohms. The RL is given as 1.5 ohms. He asked to find current through this RL or 1.5 ohms. So here current through this loop is 2 amps. Again let's take current through this loop is I, capital I. If we write loop equation in this loop, then we are going to get this RL plus Rn into I plus this 2 amps current loop is affecting on I loop by Rn resistor. So minus Rn into 2 amps, which is equals to 0. Then what is Rn? Rn is equals to 4.5 into 2 plus what is RL? RL is 1.5 plus 4.5 into I, which is equals to 0. So I is equals to 3 ja 2 ja 1.5 amps equals to 1.5 amps. This I is flowing through load resistance. Now current through load resistance is 1.5 amperes.